Welcome to New York Times Sudoku Medium puzzle for Wednesday, November 15th. And we are going to start with ones. And, ooh, look, between this one, and this one, we have a full-on one here. Between this one, and this one, we have a full-on one here, which means we have candidates there. That's fun. Between these two, we have a full-on 2 here. This 2 comes over, making this 2, 2, 2, which means 2 is somewhere in this top row. It also means 2 is already in this column, so it actually can't be that one. Okay, let's check out 3. 3 is somewhere in that row, and this column, I think that's it. Let's move on to 4. Okay, between this one and this one, that's what we've got there. Between that one and this one, we have 4s along here. Oh, and between these two, we have a full-on 4 here, which is always exciting. And that's about it. Okay, between this 5 and this 5, we have a full-on 5 here, making 2 5 candidates there. Making 2 5 candidates here, and then if you look at this row, this cannot be a 5, this can't be a 5. This can't be a 5, and this can't be a 5, so the only thing that can be a 5 is that guy. Yay, and we know that because we have these 2 5s up here, so that's how we got that 5. And that means we have 2 candidates there. And 2 here. All right, now let's move on to 6. Zwink, zwink, zwink. Ooh, between this 6 and this 6, we have an actual 6 here, which means the only place for 3 to go is there. Which means between this 3 and this 3, I'm just going to fill it in because it's there. 3, and that also makes 3 here, which is great because then we have the exclusivity, which also means in this column, the only place for 2 to be, because it can't be here, because we have the 5, 3, and the 5, 3, 2 numbers, 2 squares, nothing else can be there. The only place for 2 to be is here. So these are 2s, and then that leaves 1 square left, which we have the 1, the 2, 3 is going to be one of those 2 squares, 4, 5 is going to be one of those 2 squares, 6, 7, this has to be our 8, because here's our 9. Okay, we left off at 6 though, so let's go back to 6. 6, 6, 6, 6, 6. I think that's it for 6. 7 is going to be somewhere in that column. And that's all we've got for 7. We don't have a lot for 7 on the board yet, but we will get there. 8. Between this one, and this one, we have a full-on 8 right there. And then we have our 8s right there. 8, 8, 8, 8, so 8. And I believe that's all the 8s we have. So let's do 9s. 9s are somewhere there. We have a 9, 9 here because that's the only thing it can be. So 9s are in this column, so 9 can't be there. So looking at this top row, 9 can't be here, 9 goes there, which means, again, 5, 9 exclusivity. Nothing can go in these two squares except for 5 or 9. So that means the only number that's missing is a 3. So 3 has to go there. So 3 can't go here. 3 is here, which means this can't be a 3. So 3 has to go there, and 5 has to go here. Which also means 5 can't go here. The only other place for 5 to go in this square is here. The only other place in this square for 1 to go is then here, and the only other place for 9 to go in this square is here. Which also means that we have a 9, 9 down there, which makes a 9, 9 here. Now check it out, we have the 9, 9 here and a 9, 9 here. So if you look at this row, right, this can't be 9 because we have a 9. The 9s are going to be down here. So 9 has to be up here. And then if you see, we have a 2, 9, 2, 9 exclusivity. So 2 squares, 2 numbers. The only thing that can go in these 2 squares is a 2, 9. So if 6 goes here, we only have 1 square for both a 2 and a 9. Can't go there. So 6 can't go there. So the only place in this group of squares for 6 to go is right there. Which means can't go there. 6 goes here. Okay. What else we got? Alright, so I think, is that it for 9s? I think that is it for 9s. Which means, let's go back and fill some things in. So, the only other thing that these can be is a 2. So we're going to put our 2 candidates in there. So that means 2 has to be in this. So 2 is in this column. These aren't 2. 2 can't be there. 2 can't be there. So here we go. 2, 2. Now let's take a look at this row. This can be a 6, can't it? 1, 2 can be one of these two, 3 or 4. Yep, 4 can be there and 4 can be there. Okay, so that doesn't help us. 4. Okay. I was hoping. 5, 6, 4, 5, 6, yep. 79. Okay. 9. Here, let's look down here. 2. 2 can be one of any of these. 2, 3, 4, 5. It's going to be one of those. 6, 7 can be one of these. 8. And then 9 can be one of these. Well, that's not as exciting. Okay. 7, 8. Okay. Okay. Let's 4, 7, 9. Nope, that doesn't help. Okay. How about here? 3, 2. Oh, hey, take a look. 2 can't be here. This has to be 2. There we go. So this cannot be 2. The only place for 2 to go is here. 2. 2. Yep. If 2 is there, 2 is not here. And it can't be at one of these two, so we know that 2 goes down here. Okay. 7 does seem to be our trouble guy. Okay, so let's fill in. This is not 7, which means this can't be 7. So this has to be 7. 4. So now we're going to fill in 4, 5, or 6. Yep. Excellent. So if 7 is this top row, these aren't 7, so 7 goes somewhere down there. What else? 4. Okay. Oh, we have one square missing here, because look, in this row, 1, 2 is going to be one of these two, 3, this has to be a 4, 5, 6, 7, 8, and then 9 is going to go, so that's a 4, which means this is not, this is, the only place for 7 is here, the only place for 6 is here, and the only place for 8 is here. Phew, which means this one last square is going to be 8, 2, 3, 4, 5, 6, these are going to be 7s somewhere. We have a missing square here that has to be a 1. This cannot be a 1, so the only place for 1 to go is here. What was there before? Oh, okay. 1. And then here is also 7. Right? Yes. Beautiful. All right, so then okay. Now I do see something very interesting. Let's just make sure there's no other easier way to do this, because I don't want to do anything too convoluted. Okay, so up here we have 4s. 4, 6, 4, 6, 9, 4, 9. So 4 can go in 3 places, so you don't get exclusivity. 4, okay. 7, 7. Okay, am I missing anything? 1s are kicked. Our 2s are down here. Our 3s. Just checking really quickly because I don't want to do anything crazy convoluted. 3s. Oh, here we go. 3. Yeah, see, I don't know anything. This does not have to, this can't be a 3. The only place for 3 to go is right there. 3, 7. Boom. So then down here, 7, 7. Because again, 7 can't be one of these two, so 7 can't be there. So that's why 7's down there. So 7 is in this row already, so this can't be 7. So this is our 7. This is our 9. 9, 2. Oh, not 2. 2. The only place in this bottom row for 8 to go, because 8 can't go there, is here. So 8 goes here, so 7 has to go here. Which means between this one and this one, we have 7. which makes me think that the only thing that can go in this square is a 5. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is already taken for this square. Yeah, the only thing that can go there is a 5. Huh. Alright, just to prove it, 1, 2, 3, 4, 5 we know can go there, 6, 7, 8, and then 9 is already taken in this bunch of squares up here, so this has to be a 5. So this can't be 5, but also 5, 5, 9, 9, 2, okay, 4, 7, 4, 7 exclusivity. This can't be 8, and the only place for 8 to go anyway is right there. Okay. What am I missing? Oh, right. Ha ha ha. 4. 4. 6. 6 isn't gonna go there. 6 goes here. 9. That leaves 4. 4, 7. 7, 9. There we go. Thank you so much.